Hello, my beautiful people. I know I'm a little late to this topic, but better late than never. Recently, a bill was passed in the House and Senate called the Inflation Reduction Act, which has major implications on the future of climate change and healthcare. In other words, this is a pretty big win. Unless you don't believe in climate change, of course, in which case you came to the wrong channel, as only science and logic are discussed on this channel. Anyway, the bill will allow Medicare to directly negotiate prescription drug prices, along with a few other things such as preventing price hikes due to inflation and providing greater subsidies for marketplace coverages. All in all, great for middle and lower income individuals who have chronic health complications. And of course, just because this is a step in the right direction does not mean we should stop here. There's still a lot we need and should do in terms of healthcare and its availability to people in the US. But anyway, that's not what this video is going to be about. We're here to talk about the climate change aspects of the bill, which aims to reduce carbon emissions by about 40% below 2005 levels by 2030. 2030, people, that's 8 years from now. The bill will aim to do this by investing heavily on renewable energy, penalize greenhouse gas emissions from fossil fuel companies, and fight environmental racism. The thing is, the ability to transition has already been at our fingertips. All we needed was a push in the right direction. I'm also hoping this bill would send a message to other countries in the world, who hopefully will follow the US by example. I've been saying this for a long time now, and I'll say it again now. We can be a leader to the rest of the world on how to combat climate change. Instead of pointing fingers at each other saying we shouldn't stop carbon emissions because so and so aren't stopping, we can set an example for everyone else. Of course, just passing this bill isn't going to solve all our issues. There's still a lot to be done, of course, but I'm glad the Democrats in power haven't forgotten about Mother Earth. To me, this is incredibly exciting because I always cast my vote on whomever takes climate change the most seriously. This is one of the most important issues in my heart, and I'm going to be celebrating this a lot. Okay, so now that that rant's over, I'm all fired up and I feel like dismantling this video on climate change. Let's go.
You often hear it announced that this or that recent year was the hottest year ever. But how far back is ever?
Well, actually, if I may correct you there, whenever there's a quote hottest on record news, it usually says since when. For example, 2022 July was the hottest in the US since formal record keeping began in 1880. You don't really see reports saying hottest year ever in general because that's just not true and also incredibly vague. So already you're kind of giving a straw man, but whatever, let's continue.
So, the hottest year ever is not since the world began or even since the end of the last ice age.
And no one claimed it to be.
It's more like since a few decades ago. So, you might ask, what evidence exists that it was as warm or warmer than today in past centuries before thermometers were invented?
Yeah, so you can already see what direction this is heading towards. Oh, the Earth has been hotter millions of years ago. It almost feels like climate change deniers don't seem to understand any of the science we give to them. You're repeating the same arguments over and over again as if the debate hasn't moved forward since then. There are explanations on why the Earth has become so hot before, or if we're talking about CO2 levels, why they were high before in Earth's history. I'll go into a bit more detail later, but the temperature increases we see today is different than those in the past.
When we try to figure out what happened to the climate in the distant past, we have to decipher indirect clues left behind in things like tree rings, sediment layers in lake beds, deep ice cores, movements of tree lines across the landscape, and even observations in ancient writings. It's a fuzzy, grainy picture, and it leaves out a lot of important detail.
I mean, it would be like trying to reconstruct all of 20th century US history from Hollywood films.
Okay, that's not a really good analogy since Hollywood films have incorrect information in them too, but whatever. Our estimations are actually pretty accurate despite them being estimations. Like they said, there are a number of methods to determining temperatures in the past, and many of them are cross-checked with one another. It's not a wild guess out of nowhere, but I suppose you actually want them to be accurate in order to make your main point, huh?
But no matter how uncertain the science of climate reconstruction is, one thing that emerges very clearly is that the climate is not stable. It is a long and complex pattern of warming and cooling that, throughout the history of our planet, has seen temperatures most of the time higher than today.
I most definitely wouldn't say most of the time. That's absolutely ridiculous. Now, it's easy to look at a graph of Earth's history of temperature and say, wow, look, the Earth has drastically increased in temperature in the past before, but that's actually a mistake. When you see a graph that spans hundreds of thousands of years, any slope looks relatively steep because of the spacing of the x-axis. But when you actually zoom in to any individual spike, you'll notice that the temperature didn't rise nearly as quickly as what is happening today. And again, I can't believe I have to keep saying this, temperatures going up and down isn't necessarily bad. What really really causes real damage to climate and ecosystems is when temperatures drastically change in a short amount of time, and the warming we are seeing today is most definitely the leader in terms of speed of change. When you have the environment change so quickly, ecosystems cannot adapt because the evolution of living organisms cannot keep up, causing mass extinctions to occur and so forth. These all have downstream consequences that will eventually catch up to us. In addition, Mother Nature will go crazy, giving us more forest fires and other natural disasters. But a major difference we have today as opposed to the Earth hundreds of thousands of years ago is that we have something we need to protect this time, and that's ourselves. For the sake of argument, even if temperatures rose incredibly drastically in the past, we weren't around, so we didn't need to protect ourselves in our civilization. But now we do, especially when we ourselves is causing the temperature increases. We need to take responsibility so that we have a comfortable future on this planet.
And until we can explain why it used to be so much warmer than it is now, we shouldn't assume that we know what's behind any warming we're currently observing or have seen in the last 50 or even 100 years.
No. When temperatures rose in the past, we know why they happened. And even if we didn't, that doesn't mean we can't assume what's causing warming today. Because at the end of the day, each event has its own individual case. We know for a fact that human-emitted greenhouse gases is the primary driver of warming today. We have plenty of peer-reviewed research that comes to that exact conclusion. Regardless of what happened in Earth's history, man-made global warming today is a fact.
Here's a quick overview of the past 500,000 years, as recorded in ice core layers in Antarctica. Scientists look at the chemical composition of each layer of ice and infer what the air temperature likely was when the layer formed. What we see are repeating patterns of cold conditions that last for about 100,000 years, interrupted by warm conditions that last for about 10,000 years. The current warm period, called the Holocene, is noticeably cooler than the previous 4.
Okay, so this graph debunked your point about Earth was mostly warmer in the past compared to today, and it wasn't even a minute after you made that absurd claim. This graph is meant to give an overall picture of temperatures in the past few hundred thousands of years. But again, in this graph you cannot clearly see the drastic increases we have seen over the last few decades. And of course, this isn't meant to capture that, since the temperature measurements are taken from ice cores, and since 1880 we've had actual temperature measurements.
And here's a close-up of Holocene temperatures as recorded by ice core layers in Greenland. Notice that the climate warmed rapidly as the Ice Age ended and reached a peak warming in an interval called the Holocene climate optimum between 8,000 and 7,000 years ago. Ever since then, it's gradually been cooling, except for the Minoan warm period 3,000 years ago, the Roman warm period 2,000 years ago, the medieval warm period 1,000 years ago, and the modern warm period.
Okay, a lot to unpack here. First of all, this graph actually isn't right at all. Temperatures today most certainly are not minuscule compared to the other recent warmings that graph implies. Immediately after this, they do mention that this graph has been criticized and we should take it with a grain of salt. So yes, I'm going to do exactly that. Why even show us this graph then? Jeez. Okay, to paint a clear picture here, yes, we've had instances of other warming periods a few thousand years ago, and some of those times we've had human civilization experience them. A lot of changes in temperatures in the past are the result of Milankovitch cycles, which are alterations in the Earth's orbits. As the name implies, yes, it is a cycle, which means it causes periods of warming and cooling in a predictable manner. Earth's temperature system can be quite unstable, meaning it has multiple positive feedback loops that cause runaway warming or cooling. That's why we see such intense spikes in the past. For example, the Holocene climate optimum that you mentioned was the result of Milankovitch cycles, but when we have warming that comes about that way, that also means there will be cooling soon after, and that's exactly what we see when temperatures fall. Modern climate change is different because the warming today is not caused by Milankovitch cycles, but rather human activity, which means there isn't a reliable way for Earth to cool down in the near future. In fact, greenhouse gases can be incredibly stubborn, and it can take thousands of years for this warming to be undone by Earth's natural system. Now, each warming instance in the past has its own story. For example, the most recent and possibly most relevant warming other than the one we're experiencing in modern times is the medieval warming period, which you have on your faulty graph there. During this time, there was unusual warming that hit various areas across the Earth, such as Greenland, Iceland, South America, China, and various other areas. The cause is likely equated to a few factors, including the El Niño Southern Oscillation, which, like Milankovitch cycles, comes and goes. In addition, the warming was only regional, and the overall temperature and climate of the Earth during that time was significantly cooler than it is today. So again, I must emphasize this point. Various warming occurrences in the past cannot be properly compared to what we have today because of various differences in cause, speed, and intensity. And if you look at each individual warming period by itself, yourself, you'll know what I mean. Alright, so that'll be the end of this video. Again, I'm just happy that we're able to get something done in terms of combating climate change. It's time to stop digging our own grave and actually take responsibility for our own actions for once. Thank you for watching, and I'll see you in the next one.